My name is Mario Guerra. I'm a product manager on the Azure SDK team. I want to talk to you today about a tool we call the Record and Playback Test Proxy. As you might imagine, we do a lot of testing on our Azure SDKs. Testing against the live service can get extremely expensive, so we developed a way to run client code that interacts with Azure without actually touching the live Azure service. To give you an idea of the savings the test proxy can provide, we measured the cost of 99 runs of a single test against the live Azure service. The cost of these 99 runs was $13,000, which averages out to about $131 per test. In contrast, we were able to run 816 iterations of this same test with the test proxy, and using the $131 per test figure as a guide, we calculated a savings of $107,000 a month. We also saved developer time with the test proxy. A test suite that takes an hour and 30 minutes to run when talking to the live service can be run in 20 seconds when using the test proxy. The test proxy can be used with any of the major languages we support, including .NET, Python, Java, JavaScript, and Go. The proxy is built using .NET and can be installed using the .NET tool installation process. To use the test proxy, you must be able to modify your tests to route traffic to the proxy. This is handled via additions to the request URI and headers. Next, I'll briefly explain how the test proxy works. By default, the test proxy will listen on port 5000 for HTTP requests and 5001 for HTTPS requests. A custom port can be defined using an environment variable. Your application makes a request that is routed to the test proxy. The test proxy processes the request and saves the relevant info in a JSON file stored locally on disk. Alternatively, the request info can also be stored in cache for faster playback, which allows for client-side performance testing. The test proxy then forwards the client request to Azure for servicing. Azure returns a request response to the test proxy. The test proxy processes the response and saves the relevant response info in the JSON recording file. The proxy then forwards the response to your client code as if it was coming from Azure. When your application stops running, the recording file will have a complete record of all transactions made between your application and Azure. This recording is what allows us to use the test proxy as a substitute for Azure when running tests. Some quick notes about recording. A sanitizer is used to remove sensitive information like secrets before the info is written to disk. During playback, the same sanitizer is applied to the request and response for matching purposes. Transforms are used to modify a request or response to match what has been recorded. For example, the client ID that was recorded likely needs to be changed to match whatever the playback client ID will be. Next, I'll describe playback mode. During playback, the test proxy is once again running and bound to a specific port. The client once again makes a request that is routed to the test proxy. This time, the test proxy takes the request and looks for a matching request and response in the recording file. Once it finds a match, it sends the response back to your application as if it was coming from Azure. The live service is never touched. The test proxy is designed to make testing faster and cheaper. With a few simple tweaks to the request headers, you can take advantage of several different modes. We've already covered recording and playback using a recording file written to disk. There is another recording option where request and response data is saved in cache for extremely fast access. This mode allows you to test the performance of your client-side code. So there you have it, a brief overview of the record and playback test proxy. We hope you find this tool useful. I look forward to hearing your feedback. Thank you.